Well, I've got 211 on my laptop here, so I'm a minute late. But I guess we'll get started here. So first things first, if anybody near the back has bad eyesight, there is some small text on here, so it may be a little difficult to see. So you may want to scoot forward a little bit. Further slides in the future, hopefully I'll get this zoomed in a little bit better. So hopefully it won't be too difficult. If you have any questions at any point in time, feel free to raise up a hand, ask a question. Let some more people trickle in here. Let a few more people trickle in. All right. So I think we are ready to start. So I'm Karl Fosaaen. I work for a company called NetSpy. You may have seen me over at the table earlier in the day. We've got the cool sweatbands for the head and for your arms. Anyways, today I'm going to be talking about hacking iOS Game Center and Passbook with proxies. It's kind of a mouthful. Basically, it's hacking iOS applications using proxies. So, like I said, I'm Karl Fosaaen. I am a senior security consultant over at NetSpy. You can find me on Twitter as @kfosaaen. I know my last name is not really easy to spell, so you may want to get this off slides later. Which I should also mention, these will be up on SlideShare later. So if you find me on Twitter or find us on NetSpy, you should be able to get to our SlideShare account from there. So a little bit about myself. I'm a security consultant. I primarily focus on internal and external penetration testing, so the network level pen testing. I also do a fair amount of mobile applications and web applications. So a little bit of everything, but primary focus on network and web app. Oh, I'll also mention that my wife is actually from Kentucky, so it's nice to be down here. I'm based out of Minneapolis, and my wife hates the cold of Minneapolis, but I figured I'd mention that. So, presentation overview, we're going to be talking about intercepting iOS traffic. Why would you actually want to do that? How you can do it, the tools, certificates, everything behind that. I'm going to give you 3 examples of how you can attack native iOS applications or functionality with just a simple proxy. Then we'll have some conclusions. So, intercepting traffic. Why would you want to intercept traffic from your iPhone? I mean, iPhones are smart and cool and interesting, but why would you want to look at the traffic? Well, oddly enough, most iOS apps are basically pretty front ends for web browsers. A lot of the common apps you use, like Facebook or LinkedIn or any of your social networking, even e-commerce things like Amazon or Target, they're basically front ends for the website. They're basically making web service calls on the back end, and they're a pretty web browser on your phone. So pretty much any attacks that we would do against a normal web application, we can do against these types of applications. So that's one of the reasons why. Traffic tampering. Can you name your own price? Well, let's say you're buying something from an e-commerce application on your phone. What if you tell the phone that that TV you want to buy is not actually $500, it's actually $5? And what if the application on the back end actually trusts that? There are things like coupons that you may only get on your device from some other third-party tie-in to that application that say, hey, this actually knocks 5% off. Well, what if you can change that to 50% off? And since the back end trusts whatever third-party tie-in is happening, well, maybe it trusts that coupon. Can you submit a higher score for a game? We're actually going to show you how you can do that for iOS Game Center. That's actually a lot of fun. Server responses can actually be really interesting. So what the server sends back to you can be very interesting. This kind of ties back into the traffic tampering. Modifying what the server says to tell your app something differently. So if the app displays a $5 price, or if the server says, hey, you don't actually have access to these documents. Here's a list of the documents you only have access to. Well, what if I change that and say, you've got access to all of these documents. The application has free reign. And intercepting files, so responses from the server like files or images or whatever. Passbook passes are an example of that. We'll be going over that as well. So, the how. This is extremely simple. If you know how to use a web browser, if you know how to use your phone, if you know how to run a single program, this is about it. You fire up your proxy, you change your settings for your proxy on your phone to use that proxy. That's about it. It gets a little trickier with the SSL interception. We're going to talk about certificate pinning and why it can be a pain for interception. There are kind of ways around it, but the SSL traffic may be kind of a hurdle that you have to get over for some of this, but we're going to go over that. And traffic sniffing, even just sniffing whatever wireless traffic that's coming from your iPhone through a wireless network, you can actually find some interesting stuff in clear text. We're not going to go over that a whole lot because we're focusing on proxies. So, proxy we're going to be talking about today is Burp Suite. We've got the professional suite on our laptops at work here. I think the professional license is actually pretty reasonable for software. We use it pretty much every single day at work. So, it's a great tool. We're going to be going over how you configure that today. You can also use the iOS simulator. There are ways to tie that in. There's other proxies that you can use for proxying. However, today we're just going to go over Burp Suite. So, pretty simply, if you want to do SSL interception from the phone, a lot of the apps are doing SSL transmission between the iOS application and the backend server. So, what you'll want to do is export the root CA for Burp. So, pretty simply, if you have your browser set up to go through the proxy, go to like https google.com, look at the security information and the certificate, and export that port swigger CA. So this is the root CA that the Burp Suite program actually uses to sign all of the SSL traffic in between the proxy connection. So we're actually going to install this port swigger CA onto the iOS device. Got a couple more chairs here. Oh, he left. All right. Anyways, we're actually going to install this port swigger CA certificate onto the iOS device so that it trusts it, because we want to trust everything that the proxy is signing for us. So once you export that certificate, you will email that to yourself on your iOS device. That's about the easiest way to get it over there. You can put it up on a web server, download it from the web server. I believe that you can install it that way. Anyways, there are much more detailed instructions on PortSwigger's website. It's pretty much what I just showed you, but it's pretty simple to do. So this is what it looks like when you have it installed in an iPhone. I apologize that all of my screenshots are for iOS 6. If you've all upgraded to iOS 7, it's going to look pretty similar, just a little blurrier and not quite as. I've actually updated my iPad mini to be iOS 7, so I've actually tested some differences between iOS 6, iOS 7 with some of this proxy stuff. So you'll hear a little bit about that, but overall it's pretty much the same stuff. This process is going to be exactly the same. So anyways, we can see here that the certificate is trusted and installed. That means that anything it signs we will trust. Within Burp, you open up Burp, go to your proxy tab, and go to Options. You edit your running proxy listener. We're going to bind to port 8888. Basically, listen on all interfaces so that you can set it to your Wi-Fi interface. That's basically what you need it for. But you want to connect to the same wireless network that you're going to connect to with your iOS device, and basically tell your iOS device, hey, I want to actually send all of my web traffic through this. So the setup's really simple. Like, it's literally one setting in Burp, and you just get that running. This is the iOS proxy setup. This screenshot was taken from my home. This is my access point here. This is my kind neighbor that has a wide open Linksys wireless access point. I won't get into that. But so anyways, I've got my SSID blurred out here. Anyways, I've set my server to the Burp proxy, or my laptop that's listening with the Burp proxy. You have to set your port. We're not going to use any authentication for this. We just want to send all of the traffic through. So that's pretty much it. That's the setup. Here we can see that I made a request from my, let's see here, iPhone OS 613. Again, there's a little bit small text, so I apologize if you can't read it in the back. But you can see the user agent here is the iPhone. I'm making a search for nothing on google.com. You can see here that we are intercepting HTTPS traffic. So that's just going into Safari, hitting enter on the little search thing, and searching for nothing. But this shows that we're actually properly intercepting everything with SSL. So that's just a real basic setup. One thing to note, if you're doing this at home or with your own iOS devices, if you've got Activesync running, like your Exchange account for work, Activesync actually sends encoded passwords back and forth to retrieve your email. So it's all base64 encoded user:password. So, you know, it's kfosaaen : whatever my password is, sent in base64 encoding. If you intercept that in Burp, that's going to show up in your proxy logs in Burp. So you may want to be careful about what you actually intercept. You may want to delete some of that stuff because you may end up storing the password in your proxy. Same goes for other applications you might open. I don't know exactly how Facebook or LinkedIn or any other ones send their credentials across, but chances are you may end up with clear text credentials of your own from your device in that proxy. So be a little careful about sharing your states for your Burp sessions out with other people because you may end up sharing your creds. Mostly just watch what data is getting stored in your proxy. Like I said, you'll never know when you need to share that Burp session with somebody else. So it's just something to be careful about. Having had coworkers get passwords for other stuff, you know, you just kind of want to be careful of that. So one last thing about the whole setup and about intercepting the traffic. This is the last of the getting things set up. Identifying certificate pinned apps. So basically the application says, I'm only going to trust SSL traffic that uses this certificate from this company. It's properly signed. I don't want to trust any other SSL certs. It's a common thing that we're actually seeing now. It's a great thing. You can actually see it with some applications. I believe Starbucks is one that's using it. I know Dave Kennedy was just talking about Starbucks. It just happens to be one of those ones that I believe they're doing CertPinning on most of the application. Burp's got some interesting settings, so you can actually just not try and SSL intercept specific domains. So let's say we know Starbucks.com is one of the cert-pinned domains that it's not going to trust any other SSL traffic. We can actually put an exception in Burp to say, hey, if this application is trying to go out on HTTPS out to this domain, forget about it, let that traffic go through, we don't want to mess with that. Well, if they go out to some other third party like Facebook or some Google app or something like that through that application, and that application actually doesn't check for CertPinning, you will be able to get that SSL traffic, and you can kind of filter through that with Burp. So that's really handy. But the ways to identify it, let's say that you're able to intercept your normal browser SSL traffic, that Google request I showed you earlier, that was all HTTPS. You can do that, that's fine, everything looks like it's ready. You go into the application and you don't see anything. The app doesn't work, it gets confused, and it starts throwing errors. More likely than not, you've got a cert-pinned app. It may be cert checking. It may just be looking for, hey, does the cert actually say Starbucks.com as the certificate authority? No, okay, well, if it says that, we'll trust that. That's more cert checking, not cert pinning. Cert pinning is looking for a very specific certificate, not just parameters of a certificate. Yeah, I won't go too much more in depth on that, but we have seen both cert pinning and cert checking. Cert checking you can bypass with the right cert. Anyways, so pinning might be in use if you can't get that app-specific data. However, you may be able to work around it with any other third parties that may be tied in. We'll actually see that later on. So that's it for the setup. Does anybody have any questions about proxying the traffic between the device and the proxy? No? So that's kind of the core fundamental of this. So what we're going to be looking at today is the Game Center application for two of the examples here, and Passbook Files as the third example. Now, Passbook Files, we are going to be focusing on boarding passes today. However, Passbook Files are being used for everything, so you may actually have some on your own phone. All right. So, attack examples. Attacking Game Center. I talked about attacking the high scores here. Turns out, on Game Center, they don't validate the score updates with anything on the application. So if you say you scored a score of 9 trillion something, it believes you. It doesn't look for anything that's signed on the back end to say, hey, this is legitimate from the actual application. So It updates with an HTTP post request out to Apple servers, and it basically says, hey, this is my high score, please put this up on the leaderboard. There is no input validation on this score value parameter. There is a max score, which is the database limit of this for the big integer that we see here. So that's the max score you can get. Other people have figured this out before me. I am not any of these people. There are a couple of apps that you can get to cheat Game Center off of the jailbroken iPhone, the Cydia store, that you can use to do this stuff right here. It's the same score that I'm able to post using this attack that you would be able to post using the same kind of attack. So we can see here this is a leaderboard for the cardboard box cut the rope level. I'm number 33 out of 11 million players. I'm not that great at the game, but by intercepting the score and putting that, I'm apparently the 33rd or somewhere around there person to actually do that. So the attack process is really, really simple. Set up your intercepting proxy, start burp up, get everything set up, and intercept any traffic that's going through. So in burp, you can actually just say, intercept any requests that are outbound, and play the game. So you beat the first level of whatever game you're playing. You trigger some kind of score update to say, hey, this is the score I just had. Let's post this out to Apple. You intercept that and look for the submit scores page. So it's going to submit to a specific URL with a bunch of parameters. And you replace the score value with this massive number that I should probably actually figure out at some point in time. It's a very, very large score. So, anyways, you can see up here if you're really close, this says submit scores up here. It's a post request, and it's posting an integer value of 1, 2, 3, 4, 5. This is submitting the score for cut the rope. What we're going to do, in burp, you can modify the request. It's kind of a store and forward thing. The proxy is going to get this post request. You can modify it and then send it on to Apple. So we're going to modify 1, 2, 3, 4, 5. And you can see here, I have the high score on a number of different games, or in the top, 5 to 10% here on the number of them. So anyways, yeah, you use this massive number down here, replace the score value in the integer there, and you get the high score. Extremely simple. Like, this takes like 5 minutes to set up and do. On the downside, iOS 7 breaks this. If you've got an older iOS device, I've got like an iPod, second generation, something like that. If it's got Game Center on it, you can still do this, but they've updated Game Center in iOS 7, so it actually uses a token. And they tried to be really tricky with everything. They gzip encode that post request that we saw back here. It's still there, it's just encoded. So you can decode it and you can change it, but they've got a token that shows up as a cookie parameter that protects that. So haven't broken that yet. I'm still looking into that. iOS 7 is still pretty new, so we'll see if we can break that. But kind of a bummer. So, capturing Game Center email hashes. Game Center, I probably should have started by explaining Game Center. For those not familiar with it, it's an iOS application that ties in all of the games that you play with leaderboards. So think of it as like Xbox Live for iOS. Basically, it allows you to play games and compare scores against friends. Well, part of that is adding friends on Game Center. You want to know, how your friend is doing on that game and, compare your high scores. Well, you add them as a friend. Turns out you can actually get hashed versions of their email addresses by changing some of this proxy traffic to get a hashed version of email addresses. Now, this can be done for your friends, but this can also be done for friends of your friends. So let's say I'm friends with John. Let's say he's friends with 10 other people. I can get hashed versions of their email addresses from John because they're friends of him. So what would you want to do with these hashes? I mean, they're hashes. Well, we can crack those. I mean, they're email addresses, so that most people have pretty common email addresses. We could probably crack those and then turn around and use all of that information to potentially social engineer somebody's iTunes account or something like that. So step one, well, and secondly, it's a privacy thing. Not everybody wants their email address being out there publicly. So anyways, capturing email hashes. First step that we want to do is add a bunch of friends. I had like 2 friends on Game Center when I started doing this. I think I'm up to somewhere in the 200s now out of this. I know like 3 or 4 of those people, so yeah, we'll talk about that in a minute. But anyway, step 1, add a bunch of friends. This way you're building up your friends base as well as that network of people outside of your friends. You can get this from recommendations as well as leader boxes. So let's say that you're proxying all of your traffic from your iOS device into that proxy. When you make that request for recommendations, you actually get a list of like 50 people or so that you can parse through in that proxy. Likewise with the leaderboards, you get like the top 150 people or whatever in the leaderboard. You can get that list of user IDs, and we can turn around and turn that into the proxy. You'll see this G player ID here. You can actually turn that around in the proxy and request all of those all at once to request them all as friends. It's a little bit spammy, and it may be a little questionable if you're asking 500 people to be friends with you all at once. Apple hasn't really complained about it, so might be able to get away with it. So step 1, add a bunch of friends. Get a list of all of their friends. So that's step 2. You use this get friend player IDs. That's something you'll actually see when you're looking at the Game Center traffic. So when you log into Game Center and all of that traffic's going through your proxy, you're actually going to see this request go through when you start loading up your contacts and everything like that, because Game Center wants to know, hey, who are your friends with, or who are your friends with? I want to, get that in the queue for recommendations for people that you may want to be friends with. So we can actually abuse this. You can do this for each one of your friends. You can set up your proxy to basically fuzz on this parameter here, and you can change it to feed in a list of all of your current friends. So again, part of that traffic is you're initially going to get a list of all of your friends. You can use this request right here and pipe in that list of all of your friends in here to get a list of all of their friends. So, yeah, we want to get a list of friends and keep adding friends until we get a ton of friends. So, you see here, we've got some results for friends of friends. This is just the start of a long list of somebody else's friends. Step 3 is friend request them all. So, you start off with your list of friends, you go and find out who all of their friends are, and then you have this big list of, say, 500 people that you want to be friends with. You go in and you find the request friends request. You can actually capture that on the Burp proxy by going to somebody's profile and saying, hey, I want to be friends with them. You just capture that, and then you send it into the intruder functionality, which is basically repeat this request a ton of times. So that's a very simple way of saying it, but it's a great way to attack a website with a multiple vector kind of thing. So anyways, we're going to list out all of the different friend IDs that we want to be friends with. So we go through that, we request 500 friends. We wait, a few hours, see who comes back and accepts the friend request. You keep returning back to step 1, you list out all your friends, you find all of their friends, and then you friend request the friends of friends, etc., the leaderboards, whatever you want. Eventually, we're going to get a ton of friends in your friends list. You may think that's a good thing or a bad thing, but after we've got a nice big list of friends, we want to find out what their email hashes are. So there is a request right here. It says get profile info. There's some undocumented functionality in here called show emails hashed. I happened to notice it while I was going through some of the Game Center traffic. It's like, all right, show emails hashed, hashed emails. This might be actually pretty interesting. What that actually does is returns the hash of your friend or friend of friends email address. So what we want to do is we want to take that request and list off all of our friends, list off all the friends of friends, and then pipe that into this get profile information. So this can be done with Burp. It can be done with the intruder. This is the get profile info page, and we're going to show emails hashed. So like I said with that previous request a ton of friends, we're just going to pipe this list of basically our social network and the one hop away social network in here and get a list of all of those email hashes. So we've got some hashes. So what? Well, we also have their handle. We also have their first name and last name. When you actually request this information, and you may not see it here, but it says show accounts, show details, show emails. That emails doesn't actually show anything. Don't really know what it's for. Also show real name. So you can get somebody's first name, last name, and their handle. If you see where this is going, how do most people set up their email addresses? I know I'm Karl.Fosaaen@netspy.com. That's pretty easy to guess. So first dot last, first initial last, their handle or their username. I mean, you know, if my username is netspy on Game Center, maybe I'm netspy@netspy.com. It's not too hard to actually guess a lot of these email addresses. A lot of people use very commonly known words because it's easier to, you know, say, hey, I'm Karl.Fosaaen@netspy.com. It's a lot easier to give somebody your email address that way. It's also a lot easier for us to guess that email address. So, you know, take what you will for privacy in that. I mean, if you choose an easily guessable email address, do you necessarily feel like it should be that private? That's kind of how, I don't know. It's up to you to decide. Anyways, there's a number of different things that we can guess for that, as well as email providers. There are tons of lists out there for like the top 500 email provider domains. So, you know, Gmail, Yahoo, AOL, anybody? You know, there are a surprising number of people that I've friended with AOL email addresses, but we'll get to that in a minute. Anyways, we go through that list of top 500 email domains. So I wrote a quick PowerShell script to go through and guess all of these usernames and hash them. So, you know, given a first name, a last name, and a handle or username for Game Center, it would go through and say, okay, you know, kfosaaen@example.com, k.fosaaen. It would go through all of these different mutations and iterations and append each of the top 500 email domains to them, run a SHA-1 hash of it, and compare it against the hash that we pulled from Game Center. So, you know, if I'm Karl.Fosaaen@example.com, it does a SHA-1 hash of that, compares it to what's registered with Game Center. There we go. It matches. We've got the email address. So this was done with both a PowerShell script, and I just wrote all of those guesses out to a dictionary file and mutated on it with the Hashcat password cracking program. If you haven't used it before, Hashcat, as well as OCL Hashcat, pretty much all of those things. The Hashcat program is great. It's a fantastic password cracker. We actually use the GPU cracking with OCL Hashcat to do all of our password cracking. It's fantastic. It's amazing how fast password cracking is getting with this GPU cracking. But that's a whole other presentation topic, and if anybody has questions about that later, we can definitely talk about that. But I use the email guesses as a dictionary, so it would mutate on that. So let's say it's kfosaaen@example.com. I set up mutation rules to say, you know, kfosaaen123. You know, append numbers to the end of it. Do some guesses on it, and mutate through all of that with Hashcat. So final numbers. I actually stopped collecting records and email hashes after I got 45 friends. As of like 2 weeks ago, I have 222 friends. I can't stop the people from adding me because I keep showing up as a recommendation for other people. So I either need to unfriend everybody on Game Center or just give up on it all because I keep getting new friends added. I actually stopped collecting all of these records after 45 friends, so you can kind of get the idea of how much this starts to spider out. Even after 45 friends, I was able to get 1,600, or 1,635 records, being first name, last name, email hash, and username. So we see down here, here's a hash, here's a username, first name, last name. These are all kind of made up, but it's kind of an example of what we were able to pull out of Game Center. So, yeah, like I said, it kind of spiders out. Like after 45 friends, I was able to reach out to over 1,600 people. Some of these people had like Unicode and weird like emoji icons and stuff in their usernames because it's iOS and has the fancy emoji keyboard that you can add. That doesn't really bode well for this kind of stuff, so I kind of removed all the Unicode stuff, ended up with a little over 1,500 records. 300 email hashes were cracked, and this was pretty minimal effort. I spent maybe 4 or 5 hours, you know, setting everything up and getting this set up. If I did this now, let's see, we've got 45 friends here. I don't know, we're looking at 4 to 5 times as many friends now, which equates to a much, much larger number of like branching out social network-wise. I think I could easily clear, you know, 1,000 email hashes cracked. I don't think that would be much of a stretch. So anyways, with very minimal effort, I mean, I probably put 5 to 10 hours total into this whole thing. I got over 300, well, ended up with 300 email hashes that were cracked, almost 20%. And any of those, I've got first name, last name, and username. These could all be used for social engineering against iTunes accounts. Get access to that. I mean, I think everybody probably heard about that Wired writer. I think it's Matt Honan, I think is his last name. How his iTunes account got attacked and his Twitter handle eventually got overtaken. I mean, that was just the starting point, was, getting into his iTunes account and getting that back up and all of that. So there's a lot that can be done once you get a hold of somebody's iTunes account. So, moving on to Passbook. Does anybody have any questions about the Game Center or anything like that? About the attacks, anything? Okay. So, moving on to Passbook. Anybody in the room use Passbook? Okay, I see a couple of hands, a couple of nodding heads. I personally use Passbook myself. I used it to fly here today. I fly Delta commonly. So I get pretty much all my boarding passes through Delta and through their app on the iPhone. So there are a ton of apps available now. I think when I first started putting all of this stuff together for the presentation, there was probably 18, 19 apps that have Passbook. That's probably close to doubled in the last 6 months or so that I've noticed. So pretty much everybody's giving you a Passbook pass for everything. Some I don't even know why. Like American Express, it gives me one to let me know, hey, there was a transaction. Okay, well, I know I used my card, I appreciate that. Like, it's nice for fraud and everything like that, but some of them, like an REI member card, it's kind of handy because I don't have to keep the member card on me. Starbucks, I can keep my very nice 19-cent balance on my Starbucks card, and it's really handy. So a lot of loyalty cards, coupons, boarding passes, all of that stuff's getting adopted and integrated into Passbook now, and it's actually pretty convenient to use. My Passbook passes for Delta show up on my phone as I'm in the airport, like 10 minutes before my flight. Swipe it. I don't even have to unlock my phone, and sure enough, the Passbook pass shows up. Well, there's actually a lot of common issues with these. So even if an application does CertPinning, you can actually usually get to the Passbook pass because they're using a third party to go out and fulfill these Passbook pass requests. So instead of going to Starbucks.com to get their Passbook pass, they're going out somewhere else. We're actually going to see this in the practical example. So the failure is in securely delivering the PK pass files. The PK pass file is the Passbook pass file. Applications not using HTTPS, not using CertPinning. I mean, some of them you may not care about. Do you really care if your loyalty card is being sent unencrypted? Oh, somebody can use my Walgreens card to get more Walgreens points for me. Like, not necessarily going to care about that. However, failure to validate pass information on back-end systems is much bigger. Let's say you modify that pass and change it to say, hey, I've actually got $1,000 on that gift card, and that's what my phone says. I believe I've got $1,000 on that gift card. Whatever your back-end system says, that's what I'm going to think I have. So failure to validate that can cause some interesting situations. So, like I said, PK pass files are the Passbook files. There's actually Android apps that you can use now to load up the PK pass files, so this does kind of cross into Android territory a little bit. But the PK pass thing is pretty much primarily iOS. It's basically a zip file. If you intercept it or get a hold of a PK pass file, you can even get them from the Apple developer examples. You just right-click on it and extract it. It's a zip file. So there are some required contents for it: the manifest, the pass, which is literally the pass information. We'll kind of show some of that, and a signature. So the signature is for file integrity. It's going to prevent you from modifying the pass.json. It's going to prevent you from replacing photos, things like that. However, this can be bypassed. So instead of just changing what's in there and rezipping it and sending it to yourself, the signature prevents that. We can bypass this with the Apple Developer Program. So it's $99. You actually get a lot of really nice resources, but you also get the ability to sign your own Passbook passes. You get an Apple Developer Certificate that signs these passes with that signature file here, and then your phone trusts them. So what you can do is modify pass.json to match whatever needs you feel fit. Modify your team identifier and pass type identifier to match your Apple certificate. and re-sign it, send it to yourself, and you're good to go. So I do this from a MacBook that I've got at work. You can also do this from Windows. You need a developer cert. It's kind of a longer process to get into. We're not going to do that. It's a single command with this sign pass utility that you get from Apple. So if you've got a MacBook or something you can use, it's a lot handier to do it that way. So deployment, this can be done via email or web server. You can set up your web server to deploy PK pass files. It's basically a configuration setting to allow a specific type of file. But yeah, email is probably the easiest way. Here you can see that I emailed myself a coupon for NetSpy. Shows up as a coupon for NetSpy, and you've got all the info in here. These are really, really easy to make. There are plenty of templates that are out there. If you've got a Mac and you're able to get into this developer program, it's really easy to make these. So the attack overview with Passbook, kind of in general, what you want to do is set up your proxy, request a Passbook pass. So in the application, it's going to say add to Passbook, or pull up some kind of information card. At that point, it's going to call out to whatever service it's going to get the Passbook pass from, and that's when you can intercept it. Like I said, it's usually from a third-party site. There's not a lot of places that I've encountered that are actually doing this on their own domains. They're usually farming this out to probably 3 or 4 different vendors that I've seen that are handling Passbook passes. You can request the wrong button. You can request the pass on your own browser. You just right-click on the request in Burp and say request in original session on your browser, and then you go and copy the URL, paste it in, and you proxy all that traffic through Burp from your browser. You can actually get to the Passbook pass just with your browser. You can also save a file out from the proxy too. But yeah, at that point you've got the PK pass file. So generally we're going to intercept it, we're going to modify it, re-sign it, and use it on our iPhones. Let's see, a little bit more time here. So something I kind of talked about earlier with Burp, avoiding issues with CertPinned apps. If you can drop and forget about traffic that's CertPinned, that's great. You want to focus on the specific, SSL traffic for the PK pass files. So one way to do this is like with the Starbucks app. Since it's CertPinned to a certain point, you get to the point of where you click on the Add to Passbook button. You just double click on that home button, go over to your settings, re-enable your proxy, go back and hit Add to Passbook. That Add to Passbook is going to do a URL call out to whatever third party that's not doing CertPinning, and there you go. You're still able to get access to that PK pass file. You may not be able to get access to the actual Starbucks app or anything like that, but you can at least bypass the CertPinning for part of the application. So pretty simple bypass. It works for a number of different CertPinned apps that I've seen that use Passbook. So example time. Like I said, I fly Delta. I'm flying out of Minneapolis, so I'm primarily flying Delta out of there. It's one of many Passbook apps, but it's probably the one that I use the most. The main app does not do CertPinning. I just validated this a couple of days ago, even with the latest update. They're still not doing CertPinning, but they do request Passbook passes. So they handle all of their Passbook passes through a third party called mobiqa.net. It goes to this wallet.mobiqa.net. Anyways, yeah, basically they make a request out there for this wallet and for this Passbook entry, and it creates your Passbook pass for boarding pass. What we're going to do is intercept that, extract the PK pass file. This is a normal one. This is your normal coach. You don't have Sky Priority or anything special. This is a Sky Priority PK pass file. You see the difference? There's not a whole lot. It's 2 files. It's a footer and a footer at 2x. Literally 2 files. That's all you have to add into this to change the Sky Priority. You also have to change this pass.json. We'll show that in a second. So, yeah, it's pretty simple. You change your key for the zone that you want to be in to Sky. You can change your seat if you really want to. If you really want to be rude to whoever's working on your flight, you can say that, no, I really am sitting in seat 1A, and you can show them your Passbook pass. It could cause some problems, and I don't recommend or condone any of this. And even the Sky Priority sound, I would recommend not doing that. Anyways, yeah, all you have to do is modify the pass.json file and the footer images. Add those to the directory. You know, luckily for me, I've got other people in the office who fly Delta who also have Sky priority, so I was able to intercept a coworker's Sky priority pass and extract all of that info. So that's where we get this example today. So the example we're doing, so let's pretend that I got a PK pass file for my flight out here. I flew Delta out here. I added those those images to the directory. I modified the PK pass file to say that I am in the Sky priority zone. Then I run it through the SignPass utility on my Mac, and it's literally one line. /SignPass -p for the directory. You point it at the directory. You can see here I've got the footer images here, pass.json. It adds the signature. We do a -v to validate the pass file. It says, hey, you have a pass type ID of pass.netspy.sample. It's all valid. You're good to go. So I email that out to myself, and there we go. I've got Sky priority on my flight from Minneapolis to Louisville. I did not change my flight number or seat or anything like that. Basically, pretty much any airport that you go to, if they're going to validate Sky priority, all they're going to do is look right here. And if you've got that little emblem right there, look, oh, here's Sky priority, go ahead. So you can board early, you can go through one of the easier check-in lines, so you don't have to wait 30 people deep in the check-in line. I was actually going to show you an example from the flight I'm taking tomorrow, because I'm flying out of here tomorrow. But apparently they don't allow the digital boarding passes here, so I wasn't able to do that. So anyways, this was my flight here from yesterday. So you can see that I was able to add Sky priority, and yeah, that's pretty much it. Fixes for this: do CertPinning on the entire application, not just your own domain. Any third-party tie-ins that you may have for your mobile application, you definitely want to do CertPinning across the board. It makes our job a lot harder, breaking into these applications and getting in between that data. Better input validation. If I'm submitting something to your website, like, hey, I want to get a hold of the hashes for all of these users, you may want to be validating why they actually need those. And I will say that that is actually kind of built-in functionality. Retrieving them shouldn't be the built-in functionality, but they actually do use the hashes of emails to compare against hashes of your contact list emails. So it will hash karl.fosaaen@netspy.com, compare it against their database and say, hey, your contacts with this person, maybe you should be friends with them on Game Center. You can actually stop all of that stuff in Game Center. There's some privacy settings that you can stop to prevent your email hashes from leaking out. I should let you know that. Which goes to limiting data leakage from apps. So if somebody is requesting something like that, do they really need something like that? So if you're an app owner, you should be looking at all of the proxy traffic that you see going through your application. Take a look for any sensitive data that's going through there, any data leakage, any abuse. We've actually seen a lot of SQL injection with mobile apps. I mean, like I said, these are basically pretty front ends for a website. So we've actually seen a number of examples of SQL injection because they don't protect, because they think, oh, it's, the app's handling all of that data submission. The user and the client is never really getting in the middle. Well, if I'm able to intercept that with a proxy, I can test it for SQL injection, potentially get control over your database, escalate that into your internal network, and then go all the way up to the top. So, it's another good thing to look for. Any questions? That was probably a ton of information in a short amount of time. Got about 5 minutes left here. Yeah, here's my contact information. Like I said, my slides will be up on SlideShare. It should be under Hacking, iOS, Game Center, and Passbook. But if you go out to our website, I've got some info up on our blog as well as the main website. So yeah, that's all.